In this video, we're going to look at everything you need to know for Cambridge AS Level Mathematics 9709, Pure Mathematics 1, Integration. Let's start with finding the equation of an integral. Remember that integration is the opposite of differentiation. When differentiating, we can find the derivative and the second derivative from a given equation. Now we work in the opposite direction. When integrating, we can find the equation of a curve from the derivative. We can also find the first derivative or the equation given the second derivative. When integrating, we use this symbol. Some people say it looks like an S, and others say it looks like half of an F. This symbol tells us that we need to integrate. So when using it, we can write it like this. All this means is that we are integrating the equation of f of x in terms of x, because x is the variable in the equation. We teach you this symbol so that you know what it means, and you can use it in your exam to show that you are integrating. But you can use it if you want to. Don't waste time with this. You will not be marked down if you do not include it. When integrating, we use the following formula. To find the equation of an integral, we add 1 to the exponent of every x term. Then we divide the whole term by the sum of n plus 1. Please remember that when differentiating, your x term becomes your constant and your constant falls away. So when integrating, the constant in the original equation that you were working with becomes your x term, but you still need to find your constant c. To find c, we substitute the coordinates of the given point into the equation so we can solve. Let's look at an example. Find the following equations. Find the equation of the curve for which dy over dx is equal to 4x cubed plus 6x squared, and which passes through the point 1, 2. In this case, we are given the equation for the first derivative, and we need to find the original equation y. So let's say y is equal to integrate, let's start with our base, 4x. X has an exponent of 3. Add 1 and we get 4 all over 4. Then we have plus 6x squared, 6x. An exponent of 2 plus 1 gives us 3 all over 3. Now we can tidy this up and we get y is equal to, in the first term, the 4's will cancel. We're left with x to the power of 4. In the second term, 6 divided by 3 gives us 2. This becomes plus 2x cubed. And we still need the constant of c. To find c, we substitute the x and y coordinates, 1 and 3, into our equation. So we're going to get 3 is equal to 1 exponent of 4 plus 2 multiplied by 1 cubed plus c. If you have a base of 1, regardless of the value of the exponent, you will always get 1. So here we have 3 is equal to 1 plus 1 cubed is still 1, multiplied by 2 gives us 2, plus c. 1 plus 2 is 3. 3 minus 3 is 0. So in this case, I'm going to write this up here. C is equal to 0. So we can write the equation for the curve as y is equal to x with an exponent of 4 plus 2x cubed. Let's do another example. Find the equation of the curve for which f of prime x is equal to 2x plus 1, which passes through point 2, 9. Here we have the equation for the first derivative. So to find the equation of the curve, can say f of x is equal to 2x. When x does not have an exponent, its exponent is 1. So here we have an exponent of 1 plus 1 gives us an exponent of 2 over 2 plus 1. Our constant becomes our x term, becomes 1x, which is simply x. Now we can tidy this up. 2 divided by 2, these will cancel, and we get x squared plus x plus the constant of c. Now we can look at our point, 2, 9. Our y-coordinate is 9, so we can say 9 is equal to, x is 2. This becomes 2 squared plus 2 plus c. Now we have 9 is equal to 2 squared, which is 4, plus 2 plus c. 4 plus 2 gives us 6. 9 minus 6 gives us 3. So c is equal to 3. And we can write our equation for our curve, f of x is equal to x squared plus x plus c, which we know is 3. Let's do one more. A curve is such that dy over dx is equal to 3 root x plus 8 over x squared. Given that the point 420 lies on the curve, find the equation of the curve. Now, in order to integrate, we need to get rid of our roots and x terms in the denominator of our fractions. So let's rewrite our equation. We can say dy over dx is equal to 3x with an exponent of 1 over 2 plus 8. Let's move the x to the top. We get x with an exponent of negative 2. And now we can integrate. So we're going to say y is equal to 3x with an exponent of 1 over 2 plus 1 gives us 3 over 2 all over 3 over 2 plus 8x. Negative 2 plus 1 gives us negative 1 all over negative 1. Now we can tidy this up. We get y is equal to 3 divided by 3 over 2. The 3's will cancel, and we get 2x with an exponent of 3 over 2. 8 divided by negative 1 is negative 8, so this becomes minus 8. X with an exponent of negative 1 plus c. Now I can substitute the coordinates of my point into the equation. Y is 20, so this becomes 20 is equal to 2, x is 4, multiplied by 4 with an exponent of 3 over 2 minus 8 multiplied by 4 with an exponent of negative 1 plus c. To make it easier, I'm going to put these values into my calculator. I have 2 multiplied by 4 with an exponent of 3 over 2 minus 8 multiplied by 4 with an exponent of negative 1 is equal to 14. So now my equation becomes 20 is equal to 14 plus c. Subtract 14 from both sides, and I see that 6 is equal to c. Now I can finalize my equation. I have y is equal to 2 with an exponent, or 2x with an exponent of 3 over 2 minus 8x with an exponent of negative 1 plus c, which is 6. And this is the equation of the curve. Next, I'd like to look at the reverse chain rule. Just like we did when differentiating equations with brackets, we can integrate equations with brackets as well. The method we use is called the reverse chain rule. To integrate using this rule, make the bracket t. then integrate the equation, and then differentiate the contents of the bracket, the equation with t. Divide the integrated equation by the derivative, and finally substitute the contents of the bracket back into t. Let's look at an example. Determine the following. Here we need to integrate the bracket of x plus 4. So let's start by making the bracket t. So we can say t is equal to x plus 4. Now let's write our equation. I'm going to call it y. I'm going to say y is equal to, instead of the bracket, I have t with an exponent of 5. Now I need to integrate this equation. And I'm going to get t with an exponent of 5 plus 1, which is 6, all over 6. Now I need to differentiate my equation for t. I can say dt over dx is equal to, my x term becomes my constant, so this is 1, and the constant falls away. Now for my equation, I'm going to have t with an exponent of 6 over 6 divided by my derivative, which is 1. And when you divide by 1, the value remains the same. So this remains as t with an exponent of 6 over 6. And now all we need to do is substitute the contents of the bracket back into t. And I'm going to have the bracket of x plus 4 with an exponent of 6 all over 6. Don't forget your constant. We say plus c. Let's do another one. Determine the following. In this case, we have 4x minus 2 under a root. When differentiating and integrating, it is always easier to turn the root into a fractional exponent. So I'm going to rewrite this equation. Let's give it a bracket. 4x minus 2 with an exponent of 1 over 2. And this is the equation that we need to integrate. So let's make our bracket t. I can say t is equal to 4x minus 2, which means that my equation is now going to be t with an exponent of 1 over 2. Let's integrate this. I'm going to have t with an exponent of 1 over 2 plus 1. This becomes 3 over 2, all over 3 over 2. Let's tidy this up. T divided by 3 over 2 gives me 2t over 3 with an exponent of 3 over 2. Now I can differentiate my equation for t. dt over dx is equal to 4, and my constant falls away. Now to find my equation, I'm going to say y is equal to 2t, an exponent of 3 over 2, over 3, divided by 4. And we get 2t with an exponent of 3 over 2, divided by 3 multiplied by 4 gives us a denominator of 12. Let's simplify. 2 and 12 are both divisible by 2, and we get t with an exponent of 3 over 2 over 6. Now all we need to do is substitute the bracket back into t, and we get 4x minus 2 with an exponent of 3 over 2 all over 6, plus our constant of c. Let's do another one. Determine the following. In this case, our bracket is in the denominator of the fraction. So let's move it to the top. And our equation is going to become 4, the bracket of 8 minus x, with an exponent of negative 2. And this is the equation that we need to integrate. Let's make our bracket t. So we get t is equal to 8 minus x, which means our equation now becomes 4t with an exponent of negative 2. Now we can integrate this. Remember that dt simply means in terms of t. So in this case, we're integrating the equation 4t with the exponent of negative 2 in terms of t. And we're going to get 4t with an exponent of negative 2 plus 1 gives us negative 1 all over negative 1. 4 divided by negative 1 is simply negative 4. So I have negative 4t with an exponent of negative 1. Now I can differentiate t. I get dt over dx is equal to, the constant will fall away, and my x term becomes my new constant, which in this case is negative 1. Now my equation will become negative 4t with an exponent of negative 1 divided by negative 1. Negative 4 divided by negative 1 leaves me with positive 4. This becomes 4t with an exponent of negative 1. Now let's substitute the bracket back into t, and we get 4, the bracket of 8 minus x, with an exponent of negative 1, plus the constant of c. Let's do one more. Determine the following. Let's start by not only turning the root into a fractional exponent, but we're going to move this into the top of the fraction as well. And our equation is going to become 3, open a bracket, 5 minus 2x, close the bracket, with an exponent of negative 1 over 2. This is the equation that we need to integrate. So let's start by turning the bracket into t. I can say that t is equal to 5 minus 2x. So my equation becomes 3t with an exponent of negative 1 over 2. Let's integrate the equation, and I'm going to get 3t. Negative 1 over 2 plus 1 gives me positive 1 over 2 over 1 over 2. 3 divided by 1 over 2 gives me 6. So this becomes 6t with an exponent of 1 over 2. Now I need to differentiate this side. So I'm going to get dt over dx is equal to, the constant falls away, the x term becomes the new constant, which in this case is negative 2. Now my equation becomes 6t, an exponent of 1 over 2, divided by negative 2. 6 divided by negative 2 gives me negative 3. I have negative 3t with an exponent of 1 over 2. Finally, let's put the contents of the bracket back in, and we get negative 3, open a bracket, 5 minus 2x with an exponent of 1 over 2 plus the constant of c. Now I want to look at how we go about finding the shaded area. Let's start with the shaded area under a curve. We can use integrals to find the area under a curve, but more specifically, we find the area between the curve and the x-axis, between two x-coordinates. Remember that if I were to draw a line along the x-axis, its equation would be y is equal to 0. When looking for the area between a curve and the x-axis, we need to subtract the equation of the x-axis, which is 0, from the equation of the curve. But when you subtract 0 from any value, the value remains the same. So in this case, we just focus on the equation for the curve. To find the area under a curve, we integrate the equation. When looking for area, we do not add the constant c to the integrated equation. Then we substitute the two x coordinates into the equation and simplify, and subtract the value of the lower x coordinate from the value of the higher. Let's look at an example. Find the area under the curve y is equal to 4x minus x squared between x equals 1 and x equals 4. Let's start by integrating our equation. We're going to get 4x squared over 2 minus x with an exponent of 2 plus 1, which is 3, over 3. Now we can tidy this up. 4 divided by 2 gives us 2. We have 2x squared. To make this easier, I'm going to write our second term as negative 1 over 3 x cubed. Our next step is to substitute our given x values into the equation. Let's start when x is 1. So I can say 2 multiplied by 1 squared minus 1 over 3 multiplied by 1 cubed. If you have a base of 1, regardless of your exponent, your answer will always be 1. So now we have 2 multiplied by 1, which is 2, minus 1 over 3, which gives us an answer of 5 over 3. Now we need to substitute 4 into our x values. I'm going to write this down here. We're going to have 2 multiplied by 4 squared minus 1 over 3 multiplied by 4 cubed. Take your calculator. 2 multiplied by 4 squared minus 1 over 3 multiplied by 4 cubed is equal to 32 over 3. Let's make a note of this over here. To find the area, we now take the value of the highest x term, which in this case is 4. Our value is 32 minus 3, and we subtract the lower value. So I now have 32 over 3 minus 5 over 3. 32 minus 5 gives me 27. 27 over 3, which gives me an answer of 9 units. Let's do another example. Solve the following. In this example, we need to integrate x with an exponent of 4 and find the area beneath this curve between x values of 1 and 2. Let's start by integrating our equation. We're going to get x with an exponent of 4 plus 1, which is 5, all over 5. Now we can substitute in our x values. Let's start when x is 1. So I'm going to get 1 an exponent of 5, which remains as 1, over 5. Now let's substitute 2 into the equation. I'm going to get 2 with an exponent of 5 over 5. 2 with an exponent of 5 is 32. So 32 over 5. To find the area, we find the larger value and we subtract the smaller one. So in this case, we have 32 over 5 minus 1 over 5, which leaves us with an area of 31 over 5 units. Next, let's move on to the area between two curves. We know that an integral allows us to find the area between two curves. To find this area, we subtract the equation of the lower curve from the equation of the higher one. Then we integrate this equation, substitute the given x coordinates, and simplify as we have in the previous section. The restrictive x values are usually the x coordinates of the point of intersection of the two curves, unless specified otherwise. So let's look at an example. Find the area between curves f of x and g of x. Now, in this diagram, we can see the shaded area, but we've not been given the x restrictions, so we need to find them first. In diagrams like this, your x restrictions are your points of intersection, and to find these, we need to make our equations equal. So I'm going to say f of x, which is x squared, is equal to the equation for g of x, 2x minus x squared. We're working with a quadratic, so let's move all of our terms to the left. I'm going to get x squared minus 2x plus x squared is equal to 0. Now I have 2x squared minus 2x is equal to 0. Both of these terms have a coefficient of 2. So let's divide everything by 2. I'm going to get x squared minus x is equal to 0. Now I can take x out as a common factor. So I have x, open my bracket, x minus 1 is equal to 0, which means the x coordinates of the points of intersection have to be x is equal to 0 or x is equal to 1. Now, in the diagram, it is not always easy to see which graph lies above the other. An easy way to help with this is take your pen, put it at the top of the diagram, and draw straight down. We can see the graph g of x lies above f of x. So the next step is to subtract f of x from g of x. So I can say the equation for g of x, 2x minus x squared, subtract f of x minus x squared. I'm going to get 2x minus 2x squared. This is the equation that I need to integrate. And I'm going to get 2x. X has an exponent of 1. Let's add 1. We get 2 over 2 minus 2x squared. Add 1 becomes x cubed over 3. Now we can tidy this up. Our first term, the 2's cancel. I'm left with x squared minus, let's write this as 2 over 3, x cubed. Now I need to substitute 0 and 1, my x values, into this equation. Let's start when x is 1. So I can say, I'm going to write this down here, 1 squared minus 2 over 3 multiplied by 1 cubed. A base of 1 remains as 1 regardless of the exponent. So now I have 1 minus 2 over 3, which leaves me with 1 over 3. Now let's substitute 0 into x. 0 squared minus 2 over 3 multiplied by 0 cubed. If you have a base of 0, your answer will be 0. And remember that when you multiply any value by 0, your answer, once again, is 0. So in this case, we have 0 minus 0, which leaves us with 0. Now we can say 1 over 3 minus 0 remains as 1 over 3. So this is the area between the two curves. Let's do another example. Determine the area between y is equal to x squared plus 3 and y is equal to 5 minus x squared. When you have a squared term in an equation, we are working with a parabola. And remember that if the term is positive, we have a smiley face, but if the term is negative, we have a frowning face. So in this case, x squared plus 3 is our smiling face, and 5 minus x squared is our frowning face. And we can see in our diagram, the area lies between the frowning face and the smiling face. But again, we do not have our x restrictions, so we need to find our point of intersection. So we need to make these equations equal. So we have, let's use 5 minus x squared. We can make this equal to the second equation, x squared plus 3. Because we have a quadratic, we need to move all of the terms to the same side of the equal sign. But we've got squared terms on both sides. The rule says that you move all the terms to the side where the x term has the higher coefficient. On the left, the coefficient is -1, and on the right, +1. +1 is greater than -1. So let's move all of our terms to the right. I'm going to have x squared plus 3. Move 5, get -5. Move -x becomes positive x squared, and this is equal to 0. Now we can add like terms. X squared plus x squared gives us 2x squared. 3 minus 5 gives us -2 is equal to 0. Again, let's divide both terms by 2, and we get x squared minus 1 is equal to 0. Get x by itself, let's move -1 to the right. X squared is equal to 1. Square root both sides, and we see that x is equal to positive and -1. These are our x restrictions. Now we need to subtract the equation of the lower curve from the equation of the higher one. Our higher curve, 5 minus x squared, I can say 5 minus x squared minus x squared minus 3 is equal to -x squared minus x squared gives us -2x squared plus 2. This is the equation we need to integrate. So we can say -2, x with an exponent of 2 plus 1 gives us an exponent of 3 all over 3, plus our constant becomes our x term, becomes 2x. Now we need to substitute 1 and -1 into these values. So let's start with 1. I'm going to have -2 multiplied by 1 cubed over 3 plus 2 multiplied by 1. When you multiply any value by 1, it remains the same. So now we have -2 over 3 plus 2, which gives us 4 over 3. Now let's substitute -1 into x. We have -2 multiplied by -1 cubed over 3 plus 2 multiplied by -1. -1 cubed remains as -1. -1 multiplied by -2 gives me +2. So this becomes 2 over 3. 2 multiplied by -1 gives me -2. 2 over 3 minus 2 gives me -4 over 3. Now, the next step, we need to subtract the lower value from the higher value. So our higher value is 4 over 3, and our lower is -4 over 3. So I'm going to make some space, and I'm going to say 4 over 3 minus -4 over 3 gives us a total of 8 over 3 units. This is our shaded area. Let's do one more example. Find the area enclosed by the straight line y is equal to x plus 1 and the curve y is equal to x squared minus 2x plus 1. Once again, we have not been given our x restrictions. So to find the points of intersection, let's make our equations equal. And we can say the equation of the curve, x squared minus 2x plus 1 is equal to the line x plus 1. We have a square term, so we need to move all of our terms to the left. Get x squared minus 2x plus 1 minus x minus 1 is now equal to 0. Let's add like terms. We have x squared. Negative 2x minus x gives us negative 3x. 1 minus 1, those will cancel. So this is now equal to 0. Let's take x out as a common factor. And we have x minus 3, close the bracket, is equal to 0, which means that x is equal to 0, or x is equal to 3. In the diagram, we can see that the line lies above the curve. So the next step is to subtract the equation of the curve from the equation of the line. So we can say the equation of the line, x plus 1. Now we can subtract the equation of the curve, so minus x squared minus negative 2x minus 1. Now we can add like terms. We have negative x squared, x plus 2x gives us positive 3x. 1 minus 1 will cancel out. So this is the equation that we need to integrate. I'm going to get negative x cubed over 3 plus 3x squared over 2. Now we can substitute in our x values. Let's start when x is 0. In this case, 0 cubed is still 0. And when you multiply or divide anything by 0, it remains as 0. So 0 plus 0 will give us 0. This means that in this question, in order to find the shaded area, all we need to do is find the value of this equation when x is 3. So I can say negative 3 cubed over 3 plus 3 over 2 multiplied by 3 squared. Now I can take my calculator. I can say negative 3 cubed over 3 plus 3 over 2 multiplied by 3 squared is equal to 9 over 2. This is our shaded area. Next, let's move on to the area below the x-axis. We know that an integral shows us the area between curves or lines. When the curve lies below the x-axis, we need to subtract the equation of the curve from the equation of the x-axis before integrating. So let's look at an example. Find the area below the x-axis for the equation y is equal to x squared minus 6x. Now, before we can find the area, we need our x restrictions. And in this case, we are looking at the area between the x-axis and the curve. So to find these restrictions, we need to make the equation for the curve equal to 0. So we can say x squared minus 6x is equal to 0. Now I can take x out as a common factor. I get x, open a bracket, x minus 6 is equal to 0, which means my x values, x will be equal to 0, or x will be equal to 6. In this example, the curve lies below the x-axis. So before we can integrate, we need to subtract the equation of the curve from the equation of the x-axis. The x-axis always has an equation of 0. So we can say 0 minus the equation of the curve, x squared minus negative 6x. This is now the equation that I need to integrate. So I'm going to get 0 remains as 0, negative x squared becomes negative x cubed over 3 plus 6x squared all over 2. Now we can tidy this up. We have negative x cubed over 3 plus 6 divided by 2 is 3, becomes 3x squared. We've said in quite a few of our examples now that when x is 0, the entire term is 0. So we're going to have 0 here and 0 here. And when you subtract 0 from any value, that value remains. So in this case, to find the shaded area, all we need to do is substitute 6 into our x terms. So we're going to get negative 6 cubed over 3 plus 3 multiplied by 6 squared. Now I can take my calculator and I'm going to get negative 6 cubed over 3 plus 3 multiplied by 6 squared is equal to 36. This is the area of the shaded section beneath the x-axis. Finally, I want to look at how we go about finding the volume of a revolution. Let's start with a revolution about the x-axis. To find the volume of a revolution, we use the following formula. Now, this might look confusing and many students find this section difficult, but it is relatively simple as long as you follow the correct steps. To find the volume of a revolution about the x-axis, you need to rewrite the equation with y squared as the subject. To get from y to y squared, we simply square y. And to do this, we give y an exponent of 2. So to square the equation, put it into a bracket and give it an exponent of 2 as well. Please keep in mind that if your equation is already in the form of y squared, you do not need to square it again. Our next step, we integrate the equation, substitute the x restrictions, and solve like you would when finding a shaded area. Finally, we multiply this area by pi. To find the volume between two curves, square both equations before subtracting. Then you can integrate and solve. Let's look at some examples. The graph of y is equal to x squared between x equals 1 and x equals 3 is rotated completely around the x-axis. Find the volume generated. We need to find the equation with the subject y squared. At the moment, we have y is equal to x squared. To find y squared, we can simply square this side, which means we square this side as well. Now we have y squared is equal to x squared squared, which becomes x with an exponent of 4. This is the equation that we need to integrate. I'm going to get x with an exponent of 4 plus 1, which is 5, all over 5. Now we can substitute 1 and 3 into our x values. Let's start when x is 1. We have 1 with an exponent of 5, remains as 1, over 5. Now we can substitute 3 into x. We're going to get 3 with an exponent of 5, over 5. Take your calculator. 3 with an exponent of 5 over 5 is equal to 243 over 5. Okay, 243 over 5. Now we can subtract the lower value from the higher one. 243 over 5 minus 1 over 5 is equal to 242 over 5. We are working with volume, so we multiply this by pi. And this is our answer. Let's do another example. Determine the volume of the solid obtained by rotating straight line y is equal to x plus 2, 360 degrees about the x-axis between x equals 0 and x equals 2. Now, even though we're working with a straight line, we can tackle this question in exactly the same way as we've done all of our others. So we have equation y is equal to x plus 2. To square y, let's give it an exponent of 2, which means on the right, let's create a bracket, and we can square this side as well. Because we have a square bracket, let's expand before we integrate. So we're going to have x squared plus 4x plus 4. And now we can integrate this equation. We're going to get x with an exponent of 3 over 3 plus 4x squared over 2 plus 4x. Let's tidy this up. We have x cubed over 3 plus 2x squared plus 4x. Now we need to substitute 0 and 2 into our x values. But again, if we substitute 0 into x, all three of these terms will be equal to 0. So to find the volume, in this case, all we need to do is substitute 2 into our x values. And we're going to get 2 cubed over 3 plus 2 multiplied by 2 squared plus 4 multiplied by 2. Now I can take my calculator. We're going to say 2 cubed over 3 plus 2 multiplied by 2 squared plus 4 multiplied by 2 is equal to 56 over 3. 56 over 3. We are working with volume, so we multiply this by pi. And this is our answer. Let's look at one more example. The curve y is equal to x squared plus 1 lies between x equals negative 1 and x equals 1. Determine the volume of the solid after the revolution about the x-axis. Now please remember, when you're working with volume, with revolution, it will always be 360 degrees. If it is not stipulated, it is still 360 degrees. So we tackle this question in the same way as we've done all of our others. Our equation is y is equal to x squared plus 1. We need to square y, so let's create a bracket squared. Now we can expand. We're going to get x with an exponent of 4 plus 2x squared plus 1. This is the equation that we need to integrate. And this will become x with an exponent of 5 over 5 plus 2x with an exponent of 3 over 3 plus our constant becomes our x term, so 1x is simply x. Now we need to substitute 1 and negative 1 into our x values. Let's start when x is 1. We can say when x is equal to 1. We're going to get 1 with an exponent of 5, which is simply 1 over 5, plus 1 cubed is 1, so this becomes 2 over 3, plus 1. Now I can take my calculator. I can say 1 over 5 plus 2 over 3 plus 1 is equal to 28 over 15. It's equal to 28 over 15. Now I need to substitute -1 into x. So I'm going to get -1 with the exponent of 5 gives me -1, becomes -1 over 5. -1 cubed is still -1. Multiplied by 2 gives us -2 over 3 plus x becomes -1. Take your calculator. We have -1 over 5 minus 2 over 3 minus 1 is equal to -28 over 15. 28 over 15. Finally, we subtract the smaller value from the larger one. So I can say 28 over 15 minus -28 over 15 is equal to 56 over 15. We are working with volume, so we multiply this by pi. Finally, I'd like to look at volume around the y-axis. We have not seen this in an exam the last few years, but it is in the syllabus, so make sure you learn this. To find the volume about the y-axis, we use the following formula. This is similar to the volume about the x-axis, except now we use x squared. To find the volume, we make x the subject. Then we square both sides, so we have a subject of x squared. Then you can integrate the equation and substitute the limits given according to y. Finally, find the area between the restrictions and multiply by pi. Let's look at an example. Determine the volume of the solid rotated about the y-axis for the following equations. Y is equal to 3x between y is equal to 3 and y is equal to 6. We need x to be the subject, so let's divide both sides by 3 and our equation becomes y over 3 is equal to x. We need x squared, so let's square one side, which means we can square the other. Now our equation becomes x squared is equal to y squared over 9. We need to integrate, so let's rewrite our equation as 1 over 9 y squared. To integrate, we're going to get 1 over 9 y with an exponent of 2 plus 1, which gives us y cubed over 3. And this becomes, right over here, y cubed over 9 multiplied by 3, which is 27. Now we can substitute in the given y values. So let's start when y is 3. And this becomes 3 cubed over 27. 3 cubed is 27. So now we have 27 over 27, which gives us 1. Now let's substitute 6 into our y value. We can say when y is equal to 6, this becomes 6 cubed over 27. Let's take your calculator. We have 6 cubed over 27 is equal to 8. Now we can subtract the lower value from the higher value. 8 minus 1 is equal to 7. We are working with volume, so we multiply this by pi. Let's do another one. Determine the volume of the solid when y is equal to x minus 3 between y is equal to 0 and y is equal to 6. We need x to be the subject, so let's move -3 to the right, and we get y plus 3 is equal to x. We need x squared, so we can square one side, which means we can create a bracket and square the other. Because we have a bracket squared, let's expand. So we're going to have x squared is equal to y squared plus 6y plus 9. This is the equation that we need to integrate. And we're going to get y cubed over 3 plus 6y squared over 2 plus 9y. Let's tidy this up. We have y cubed over 3. 6 divided by 2 gives us 3. So this becomes plus 3y squared plus 9y. Now we can substitute in 0 and 6. If we put 0 into our y values, all three terms are going to be 0. And you cannot subtract 0 from a value. So to find the volume, all we need to do is find this equation when y is 6. So we're going to have 6 cubed over 3 plus 3 multiplied by 6 squared plus 9 multiplied by 6. Now you can take your calculator. We have 6 cubed over 3 plus 3 multiplied by 6 squared plus 9 multiplied by 6 is equal to 234. So we have 234. We are working with volume, so we multiply this by pi.